So here's a notation. We say an is similar to bn is similar. So an twiddle bn. We say that an is similar to bn if this is true. So for example, as an example, um, you see this thing here is similar to this thing here because as n tends to infinity, you can see that this whole thing here equals 1. So we've seen this many times in the past. So this thing here is similar to this thing here. The reason why we're doing this is because it is because of this. Suppose you get given something complicated like this. Um, as n gets bigger and bigger and bigger, this whole thing here, as n gets bigger and bigger, this whole thing here can become 7n to the power 5 because as n gets bigger and bigger and bigger, this thing here is going to be irrelevant. This thing here is going to be irrelevant. This is just going to dominate everything. So as n gets bigger and bigger, let's just look at this. We can consider this thing as well. As n gets bigger and bigger, this will be irrelevant. It will be irrelevant in comparison to this. So as n gets very, very big, let's say 10 to the power of, I don't know, something like this, to the power of 4, it's going to be irrelevant in comparison to this. So as n gets bigger and bigger, we consider this thing here as this 7. The point is that this thing here is going to be, well, it's going to be 1 over 1. So we know that this limit here, the limit here equals 1. So you can, if you want to, say that this is similar to this. So this is similar to this. So hang on, we will put it to use later on. The reason why we're doing this is because when you get given a complicated series from n equals 1 to infinity, or it could be anywhere, let's say 7. It doesn't matter where you start. It could be anywhere. So you get given a complicated series like this. So you would find a simple one that's similar to an, and then if this thing here diverge, then this whole thing here will also diverge. If this thing here converge, then this whole thing here will also converge. So let me give you an example, then see what I mean. So suppose you get given something like this. So as n gets bigger and bigger, as n heads towards infinity, well, in your mind, visualize this. In your mind, this becomes 2n squared, because as n gets bigger and bigger, this thing here is going to be irrelevant. The only thing that really matters is this dominant term. So as n gets bigger and bigger, looking at the denominator, this thing here will just become n to the power of 4. So you can see that this thing here is similar to this, and then the denominator here is similar to this as n gets bigger and bigger, as n heads towards infinity. So looking at this, hang on. So why is this similar to this? Well, if you look at this, if you get this and then divided by this, it does equal 1. So remember, the definition of similar is that if you look back to this, definition of similar is the definition of similar is when one thing divided by another thing equals 1 as n tends to infinity. So going back to down here, hang on. Going back to down here, going back to down here, going back to down here, this thing here is similar to this, because if you get this divided by this, as n gets bigger and bigger, it equals 1. So this thing here is similar to this. The point is that you get given, hang on, the point is that you get given something complicated like this, but as n gets bigger and bigger, consider this thing here as 2 to the power of 2n to the power of 2 over this thing here, n to the power of 4. So you get given something complicated like this, but because n is heading towards infinity, when n heads towards infinity, this whole thing here can be considered as this whole thing here. So when given something complicated here, as n gets bigger and bigger, this whole thing here can be considered as this. So now this is easier to work with. So now this is a constant, you can take it out, that will then give you this, and we've seen this many times in the past. Remember, well, this thing here, we've seen this many times in the past. This thing here will converge. This thing here will diverge, and then anything above 1 here will converge. Anything below 1, it will diverge. So we've seen this many times in the past. This thing here, because it's bigger than 1 here, this thing here will converge. If this thing here converge, then when you times 2, it will converge. So therefore, well, we know that this thing here is going to converge. So therefore, this complicated thing here will also converge. Okay.